examples here. These are examples of no linear correlations. If it makes like a parabola shape or it makes it just no pattern, that's a no linear correlation. We've got some like this. We would call this maybe moderate linear correlation, to where it's kind of somewhat strong. And the strength of the correlation is how close we could draw, how close the points would fit to a line of best fit. So if we drew a line through the points, the line of best fit, how close are the points to that line? You see here on a moderate one, they're kind of close. Perfect one, they're on the line. If it was strong, it would be close to the. So the closer the points are to the line, the stronger the correlation. And R is what we call the correlation coefficient. And so R has to be between -1 and 1. And so how this works is, if it's -1, that means it's a perfect negative linear correlation, which like rarely happens in the real world. This would be R of -1. R positive 1 means it's a perfect positive. So the closer it is to -1 and the closer it is to positive 1, the stronger it is. The closer it is to 0, the weaker it is. So if it's at 0, it'd have no linear correlation. Okay. And so if it's positive, that means as X increases, Y tends to increase. If it, like just like the first example, negative means as X increases, Y decreases. And so also the R does not change whether we flip the variables, and it does not change when we convert to different units. Okay, so those are some things about that. So as I was saying here, just a lot of notes here. 0, it would just be all over the place. -1 and 1 be perfect. And then between 0 and 1, that'd be looks pretty strong there, moderate to strong, and that'd be a strong negative. Okay. So I say all that to say this. Let's look at an example. We're going to actually do this. And so what we could do is we could do the scatter diagram. You could also use your calculator to do this. I'm going to show you how to use your calculator. Sand driven by wind creates large, beautiful dunes at this Great Sand Dunes Park in National Park, Colorado. Of course, the same natural forces also create large dunes in the Great Sahara in Arabia. There's a linear correlation between wind velocity and sand drift rate. Is there one? Let X be a random variable representing wind velocity, and let Y be a random variable representing drift rate. A test in the site gave the following information about X and Y. Okay, so how can you do this using your calculator? We press stat edits. So stat edit. So stat edit. We'll put the X as an L1 and the Y as an L2. So the X is in L1. You could clear the list if you want. Go up there to the top, clear down. 70, 115, 105, A2, 93, 125, 88. L2, 3, 45, 21, 7, 16, 62, and 12. And so what this does for you, this does a variety of things for you. We could use this for a variety of applications. Okay, we could use this to create the calculator will create a scatter plot for you. The calculator will also calculate the R value. We'll find out tomorrow. The calculator will calculate the line of best fit for you, as well as doing the coefficient of determination, which is R squared. Now, how do you see the scatter plot? So I'm going to do something. It's going to be a little trashy here. I'm not going to do the nice sketching it on the first one. I'm just going to sketch what my calculator says. Okay, and it's not going to be perfect, but the purpose of this is to see the correlation. So how do I get a scatter plot? I press second Y equals. So second Y equals. And then I select plot 1. Select plot 1. It'll be on. On, and then we go down. We want the scatter plot. We want this one selected. This right here is the scatter plot. It's the first one, so you want to select that one. X list, and you don't have to write this down. I'm just showing you. X list is L1. Y list is L2. Okay, and that's all good. Okay, it's all what you want to see. So we turn it on, and then now what you're going to do is you're going to press Zoom 9. Zoom 9, which is Zoom stat. And this will show you, this will customize the zoom to fit your stat plot. Zoom 9. Ignore the line in there. Let me clear these out. Graph. Okay, so there's your, And you know what? Like, I'm not going to waste my time today doing like plotting these nice. I'm not going to plot it nice like I did on the first one. I'm just going to sketch this graph, okay? So I'm going to sketch this because what we're trying to do today, we're trying to analyze and see, is there a correlation here? Is some type of correlation? Is there a pattern here in the dots? Um, what would you say? Do you expect R to be positive? What would you say? Yes. So we expect R to be positive, yes. And so you could do a line of best fit through there. We'll talk about that in a moment. Now, determine the value of R. I'm making two separate videos for this. I'm going to do one where I do the value of R using the calculator. Then I'll make a separate video to show you the two ways to do it by hand, which I'm still having to use a calculator for. The simplest way to find R is to use our calculator. Now, first thing we got to do is, though, is we've got to turn this on. We got to turn stat diagnostics on. So I'm going to select mode. See, mine are off right now. Stack diagnostics and turn it on. So mode, stat, diagnostics, and then on. Okay, you don't have to write that down if you don't want to. I'm just trying to keep notes here. And then once they're on, you can press second mode to get out of there. Then we'll go to stats, calc, linreg. Stat, calc, linreg. It's option 4. You can also use option 8 as well. And now tomorrow we're going to use this to do a line of best. This actually tells you the equation of the line of best fit, but for now we're going to use this to find R. Now this is completely optional. You can store this equation, the equation that's made, the line of best fit, into the graph. So I could store it into Y1. I do alpha. Let's see. I'm trying to remember how we do this. Is it alpha trace? Yeah, it's alpha trace. You do not have to do that. So I did alpha trace. I usually don't do that. I'm going to calculate. We will talk about A, B, and R squared tomorrow. A and B are the line. A is the slope of the line of best fit. B is the y-intercept. We're going to do that tomorrow. R squared is the coefficient of determination. All we need today is R. Okay, 9.485. I don't need to go that far. It was 0.949. Okay, sorry about that. I don't need to go that far. R is 0.949. Okay. Now, what does that mean? You could say, very simple, as x increases, it's positive, y tends to increase. Now, if we want to go deeper, we don't go too deep with R in this class, but this 0.949, is that close to 1? Yes. So if it's above 0.8, we call in stats, we say that's a strong correlation. We say it's a strong correlation. So anything above 0.8, we say is a strong correlation. I could press graph. I stored the line of best fit in there. So you see how, for the most part, the points are pretty close to line of best fit. So that's why it's strong. Okay. I will make a separate video later that shows you how to calculate that by using the formulas. There's two formulas you could use.